Okay, so hopefully you've got all your booklets for trigonometry. Now this is part 1 of 2 of trigonometry. Trigonometry is a big topic, so we're going to split into 2 parts. We'll see how far we get today. Alright, so let's start page 2. Okay, so we're going to start off trig with right angles. So this should all be just revision. Okay. So recall, if you've got a right angle triangle, the hypotenuse is the side that's opposite the right angle. The corner points to the hypotenuse, it's the longest side of the right angle triangle. Opposite there is opposite to a reference angle, and reference angle is usually theta. Okay. Adjacent means next to, it's the side next to the angle that's not the hypotenuse. Okay, and we usually denote hypotenuse H, opposite O, adjacent A. So here we go, we're going to label in relation to theta first, HOA. So here's theta, that's my reference angle. So I usually label H first, corner points at H, opposite the angles there, adjacent's there. Here we're doing it in reference to angle alpha. So now the opposite's going to be over here for alpha. That's going to be the adjacent, and the corner points at the hypotenuse. A recap on the 6 trigonometric functions. Okay, so don't worry that it says for acute angles. We're just focusing on the 6 trigonometric functions. Sine, cosine, and tangent you should know. The way you remember these is obviously so, ka, tawa. Okay, where sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, the reciprocal relationships, I think you did look at these in year 10. So cosec is basically sine flipped, so it's hypotenuse over opposite. Sec is cos flipped, so it's hypotenuse over adjacent. And cot is tan flipped, so adjacent over opposite. And the way you remember which one's which, that cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan, as you look at the third letter. So cosec, its third letter is S, so it's 1 over sine. Sec's third letter is C, so it's 1 over cos, and cot's third letter is T, so it's 1 over tan. So you remember the reciprocal ratios by looking at the third letter. So we call it the third letter rule. Use the triangle below to find cos A. So, well, this is the hypotenuse. This is my reference angle A. So that's adjacent, that's opposite over here. So cos is adjacent over hypotenuse. So that's just going to be 3 over 5. Sec, third letter rule, it's 1 over cos, right? So all you do is you take the answer for cos and you flip it. So that's 5 on 3. Cot is 1 over tan. So tan is opposite over adjacent, so you'd use Pythagoras' theorem to quickly work out the opposite. So it's a shorter side, so we minus the squares, or you should know 3, 4, 5 triangle, right angle triangle, opposite's going to be 4. So if you got tan A is opposite over adjacent, which would be 4 over 3. And cot's going to be tan flipped, so it's going to be 3 over 4. Alright, moving on. If A is an acute angle and cos A is 2/3, find cosec A. Okay, so cosec is 1 over sine A, using the third letter rule. This is just a little aside. Sometimes cosec is written CSC. I don't like that, because it doesn't follow the third letter rule, and you don't often see it. So keep writing cosec as cosec, but I thought I'd just write it there. And sometimes you see cosec written shortly as CSC, but I never use that. Okay, so here we're given one trigonometric ratio and we're asked to find another. The easiest way is to draw a triangle. Okay, we're not going to worry too much about why it says is an acute angle. I think the key thing is here we're focusing on right angle triangles, and the angles inside a right angle triangle is always acute. Okay, so cos is adjacent over hypotenuse, so I'm going to put the adjacent as 2, the hypotenuse is 3. I'm going to use Pythagoras' theorem to work out that this is root 3 squared minus 2 squared, which should be root 5. Okay, so sine of A would be opposite over hypotenuse, which is root 5 on 3. Okay, so cosec is going to be that flipped, which is going to be 3 on root 5. In trig, angles are usually measured in degrees, minutes, seconds. Okay, you should know this, you learnt this in year 10, that 1 degree is 60 minutes, and minutes is dashed there. 1 minute is 60 seconds, and seconds is 2 dashes. For all calculations at the moment, let's make sure our calculator is in degree mode. Check that there's a D or a DG at the top. And if your calculator says R, Rad, G or Grad, change your mode. So I think you'll find it in the setup. To enter angles involving degrees, minutes, seconds, we use the degrees, minutes, seconds button. Most of your calculators will have this. Some people who've got older calculators might have a DMS button. So that's degrees, minutes, and seconds button. Some people just call it the bubbles button. So if I want to put in sine 23 degrees, 16 minutes, I'd write sine 23, hit the degrees, minutes, second button, 16, hit the degrees, minutes, second button. One thing to be aware of, sometimes your calculator displays it, it just keeps using the circle. Just know that that means the exact same thing as that in terms of your calculator display. Working out, setup, rearrangement, answer, 3 lines. Okay, so find x in the following triangles. So I've got opposite and hypotenuse, so therefore I'm using sine, right? So sine 60 degrees, always next to the trig ratio is the angle. Here's the opposite x over the hypotenuse 5. X is up high, multiply, we get 5 times sine 60. Okay, into your calculator you'll get your answer, which is 4.33 to 2 dp. Next one, here I've got opposite and hypotenuse again, so once again I'm using so sine, here the angle is now 70 degrees, opposite on top, so 5 on top, x down the bottom. Easy way, letters down low, switch with trig ratio, so we times by x and we divide by sine 70. So into your calculator you should get 5.32 to 2 decimal places. Here got our angle in degrees and minutes, it's fine. We've got opposite, we've got adjacent, so therefore we're using TOA. Okay, so tan. Whenever you don't know the hypotenuse, you use tan. So tan of the angle, 51 degrees, 30 minutes, is equal to the opposite x over the adjacent 37. X up high, multiply, so 37 times tan, 51 degrees, 30 minutes. Okay, make sure you enter it in correctly using the DMS button after the 51 and the DMS button after the 30, and you should get 46.52 to 2 decimal places. Okay. Whenever you want to find an unknown angle, we use the inverse trig ratio. So inverse sine, inverse cos, or inverse tan. Okay, just one thing to be aware of. Sometimes they call this arc sine, arc cos, and arc tan. Okay. That notation actually seems to pop up in extension 1 a little bit. We'll look at that a little bit later. But the key thing is to do this in your calculator, you need to press shift first. So shift sine will get you inverse sine. Shift cos will get you inverse cos. Shift tan will get you inverse tan. So whenever we're finding an angle, we'll do that. And then we often, after we get our answer, use the DMS button to convert from a decimal into degrees, minutes, and seconds. Okay. Remember, if you're in degrees, minutes, and seconds, you round up if you're 30 or more, round down if less than 30. Okay, the reason why is because 1 degree is 60 minutes, so 30 and higher will round up. Okay, 1 minute is 60 seconds, so 30 and higher will round up. Okay. Let's do this one. The first one says to answer the correct to 2 decimal places, so we won't need to hit the DMS button after. Alright, so what have we got? We've got opposite. Hypotenuse we don't know. We got adjacent. It's going to be TOA tan. So tan of the angle theta equals to O over A. So 9/7. If you want to work out theta, you do shift tan or inverse tan, 9/7. And in your calculator, you'll get an answer. I got 52.125 ... which is 52.13 to 2 decimal places, and write the degree symbol in. Alright, next one. It says nearest minute, so we're going to need to hit that DMS button. We've got adjacent and hypotenuse, so we're using cos. Cos of the angle theta equals to 8.7 over 15.3. Okay, so to find the angle we need to shift the cos. So shift cos or inverse cos 8.7 over 15.3 into your calculator. Then you hit the DMS button and you'll get theta equals to 55 degrees, 20 minutes, 43.55 seconds. And we want it to the nearest minute. So we look at the seconds here, 43.55, that's more than 30. Because that's more than 30, we need to round up. So that becomes 55 degrees, 21 minutes. And I'll put in brackets, nearest minute. Okay, I'm going to give you a little bit of time just to work on 2.1. It's a short exercise just to dust off the cobwebs. I'll see you in the next video, maybe in about 10 minutes time.